Differentiate e to the x to the 2. The outermost function I can see here is that e to the something differentiates to e to the something. We're now done with that e. Multiply. The derivative of that inside function, which is x squared, differentiates to 2x. There are no more inside functions, so we're done. Differentiate secant of sine of tan of square root of theta to the 3. The outermost function here is secant, and secant differentiates to secant tangent. Sine of tan of the square root of theta to the 3 is unchanged in the argument of secant. In this particular case, secant differentiates to sectan, so therefore we have the same argument for both sec and tan. We're now done with secant, so we multiply the derivative of the inner function now being sine. Sine differentiates to cosine, and again, we do not change the argument of sine. We're now done with sine. The function inside sine is tangent. Tangent differentiates to secant squared. The function inside of tangent is the square root of theta to the 3. I find this notation really difficult to differentiate. That radical is awkward to me. I like to interpret the radical as a fractional power, therefore we will have theta to the 3 over 2. That's easier to differentiate by the power rule. We bring the power down, 3 over 2, subtract the power by 1. Think of it as numerator, subtract denominator, so 3 minus 2, that's 1. The power is 1 over 2. Differentiate, but do not simplify the function f of t equals 5 over the square of cosine e to the t squared minus 7t plus 1. There's a lot of different functions inside of each other, so we're going to apply the chain rule. The first thing I noticed about the outermost function is that it is a division. It's 5 over something. We can use the quotient rule, but how about we just rewrite that denominator as a negative power? That way we can use a power rule, because I personally don't like to use a quotient rule. We need to pay attention to the order of numerator and denominator and what's subtracting what. I just find a power rule more straightforward. The numerator here in this case is just a 5, so it really doesn't need something as sophisticated as the quotient rule. Rewriting f of t, the 5 is just a constant coefficient. We just set that aside, and then it's that stuff, the 2 and everything in that square. That is in the denominator. In order to write that denominator as a numerator, we need to rewrite the power as a negative. Let's start differentiating. That negative 2 power, we bring that down as a coefficient, and then subtract the power by 1. We're now done with that minus 2 power. Multiply. Going inside, we have cosine. Cosine differentiates to negative sine, and we keep the argument the same. We're now done with the cosine. We multiply on the derivative of the inner function. The next inner function we have is the exponential. E to the something, the derivative of that is e to something. We're now done with the e, and then multiply the derivative of the inside function, which is t squared minus 7t plus 1. It's easy, it's a polynomial. 2t minus 7. Just a word of caution, that multiply sign applies to both the 2t and the minus 7. It's not like we're going to multiply by 2t and then minus 7 of that. It's actually multiplied by the derivative of that entire inner function. That's why the brackets envelop both 2t and minus 7.